Welcome back to our Learn to Code series. We're hopping back on into Learn to Code number 1. We're going to be exploring while loops. So what if you don't know how many times to repeat something? You could guess, or we could actually use a while loop. So in this episode, we're learning how to write code that keeps running as long as a condition is true, like while there is a gem, collect it. While the path is clear, move forward. It's coding with real logic, and it's how apps handle everything from loading screens to different game AI, enemies and things like that. If you've already learned for loops and conditionals, this is your next step. Let's jump into while loops and Swift Playgrounds. And don't forget, while watching, to like and subscribe. Ha ha ha. Okay, so when you're hammering a nail, you can't just hit it a certain number of times and expect it to go in all the way. Instead, you continue hitting that nail while it is sticking out. You can use while loops to repeat a command or a set of commands while a condition is true. So while nail is sticking out, hammer nail. When nail is sticking out is now false, hammer nail stops running. The nail is all the way in the wood, no longer sticking out. We don't need to hammer it anymore. Go ahead and start coding, and we're going to be starting off with running code while ... I thought there was like a longer title, but it's just running code while. All right, we have Byte joining us again. We've used Byte a couple times. Maybe we'll swap it up to Blue real quick. While Blue's getting situated, so our puzzle has a line of switches with a different number of switches each time the puzzle runs. Currently, this one is full pretty much, and all but one are activated, but with our other conditional kind of playgrounds, it will be different every time we run it. So our goal is to, just like with if statements, determine when our code's going to run. So the while loop looks at those Boolean values. So if you remember true or false, while the condition is false, the while loop stops, and while the condition is true, the while loop runs. We need to choose a Boolean condition for our while to determine when it will run. Okay, so we have open and close switches. So I think what we're going to do is while we're on a closed switch, we can go ahead and toggle the switch, and then we'll want to move forward. Again, when we run this code, we might have a different, scenario, but let's see what happens. Okay, so this time we only have a few switches. It looks like it will probably always end in a closed switch, but honestly, we're basically just going until we reach the switches that are closed. Okay, so that seems to have been the solution. We can run this again. Oh, let me go back. So we can run this again. And yeah, every time we do refresh the playground, the last switch is indeed one that's kind of already toggled. So this code should work for this playground. So every time that we're on a closed switch, we toggle it and then we move forward. So we're on a non-toggled until we reach the end, which always apparently has a toggled switch. Now, if you wanted to go a step further, you can, instead of doing is on close switch, we could use those logical operators we've used before. So while, we'll use our exclamation point for the inverse. So while is on open switch, again, the exclamation point is going to essentially say while not on open switch. And we can use our logical operators from before in order to accomplish the same goal. So, we're not on an open switch, so let's toggle it and move forward, right? So think about how you can use logical operators. Think about how you can use the while loops and all the things that we've been learning together in tandem. Good job, Blue. And let's go ahead and head over to the next playground. So our goal for this one is to use an if statement to open all the switches. To solve this puzzle, we'll need a while loop to toggle every open switch along the 3 platforms. However, we can't use the condition is on closed switch, or it'll stop running when we reach the portal. That's right, because the portal is not considered a switch. We need to add a condition to make our character move forward until they reach the end of the 3rd platform. Is there something special about the end of the 3rd platform? Also, I want to double check to make sure that the pattern's the same. Oh no, okay. It does update every time we run the playground. So the portals remain in the same spot, but the state of the toggles, or sorry, the switches, they're random. In our while loop, we're going to use an if statement. Okay, let's go ahead and enter some code, and you can either type it out or you can use the autofills here at the bottom. So let's start by putting our while, and we can look at our conditions. So while is blocked left, right. If I recall correctly, is blocked means we can't move forward anymore. But we don't have a is not blocked. Well, remember, we can use our exclamation point. So while is not blocked, essentially, with this exclamation point now, what do we want to do for our code? We know we need to use an if statement. Let's go ahead and add one of those as well. We need to make sure if we're on the switches that aren't active, which should be the close switch. So if is on close switch, so any of these gray ones, we'll need to toggle the switch. Now, I wouldn't also include the move forward in this if statement. Instead, I would keep it still within this while block. Remember, you can hover on these braces and kind of see what's all being encapsulated, even if we hover on the if, right? We need to be outside the if statement and then move forward. So this essentially says, as long as we can move forward, we're then going to immediately check if we're on a close switch. We'll then toggle it. Otherwise, we're just going to continue moving forward. Okay, so let's go ahead and run our code. It's going to refresh. Well, let me do the step through my code as well, so we can watch it in real time. Okay, so while we're not blocked, so we're going to toggle the switch. We're then going to move forward. Are we blocked? Nope. Are we going to close switch? Let's toggle it. Are we blocked? Nope. Are we going to close switch? Nope. Okay, then we're just going to move forward. There we go. We have two switches that are already toggled, so we're not going to mess with them. We're just going to continue to move forward through our while loop. It's also nice because we didn't have to, write a certain amount of numbers or like math it out, right? Count all the tiles. I remember in one of those, the amount of tiles you needed to get to the end changed. I think I had to do it 3 times because it was like, nope, we've changed the number of the loops you had to do. I was like, what is going on here? There we go. I'm gonna move forward. Toggle that last switch. And now we are certainly blocked, but we can no longer move forward. Okay, wonderful. Let's head on over to the next one, choosing the correct tool. So this puzzle has 6 gems in a simple pattern. Kind of have like this diagonal going on here. We also have a teleporter. We need to identify the pattern in order to move from gem to gem. Then we need to choose a type of loop and use it to solve the puzzle. Interesting. I'm going to definitely say probably going to use a while loop, and we already have our function turn and collect gem created for us. The question now is, can we use a function within a while loop? Absolutely. Next session becomes, how do we figure out this logic? So we look at the turn and collect gem. So we move forward, we turn left, move forward, collect gem, and turn right. And we want to loop through that pattern consistently. So I'm just going to call the turn and collect gem real quick, just so we can see it in action one time. So move forward, turn left, move forward, collect the gem, turn right. Okay, so that totally makes sense. And then we would move forward, turn left. Right, that seems like we have the logic really handled for collecting the gem, but it's just a loop part now. So we want to use a while loop. We'll say while. How can we determine the condition here? Are we looking for the block left, right, block in front of us? I think we're going to use the is not blocked again. So while we can basically still move forward and repeat this pattern, because essentially at the end, we're going to be blocked from moving forward. So let's do our inverse of is blocked. Then add our brace. And within the code, we should be able to just call upon the turn and collect gem function. Let's go ahead and step through the code so we can watch it in real time. So anytime that we're not blocked, we're going to repeat this. And even, see here, we're like a little bit blocked in front of us, but because we need to go through the entirety of the function before we check the while loop condition again, we're able to successfully go through this loop. So we're going to go through the teleporter, move forward. Whee! There you go, Blue. Turn left, move forward, collect gem, turn right. We're not blocked currently. We're going to repeat the loop until the very end. And I'm sure there's multiple solutions. There might be one that's a little bit, a little bit more code heavy, a little bit less code heavy, but this solution seemed pretty straightforward to me. While we're not blocked, the turn and collect gem function that we tested kind of just handles most of it for us. We're now blocked. We can't move forward. We can't go into that water. So the while loop ends. Oh my goodness. I just opened up the side tab here. We have a lot of while loops to get through. We're on 4x4 now. So for this challenge, there's several ways to beat the puzzle. We can use while loops, for loops, or a combination of both. Ooh. I'm thinking I'm going to use a for loop first, but maybe we can also explore the while loop. The for loop seems to make a lot of sense in my head as we have this square pattern. So even if it isn't apparent, we have this teleporter here, and we almost have like this pattern of squares, right? We have 1, 2, 3, and then the space here. 1, 2, 3, another toggle. 1, 2, 3, toggle. 1, 2, we're over here now where my mouse is, which I don't know why it's not the normal cursor. 3, and then the toggle. So the teleporter might throw you off, but we essentially have a square pattern. So I'm going to loop through this 4 times to get to all 4 corners of our square, right? Even though the teleporter does make things look a little bit funky. So we're going to use our for loop, and you can either type it out or you can use the placeholder. We should have 4 repeats of this. And we determined that even from the first one, we have to move forward 1, 2, 3 times. So 1, 2, 3, move forwards. You can even loop through this as well with another for loop or make it a function. And then we're going to want to say, okay, if we're on a closed switch, remember every time we refresh this playground, it's completely random what's on or off. So we'll use an if statement. If is on closed switch. Then in our code, we're going to then toggle the switch. Afterwards, we do need to turn. So if we're facing here, we'll need to be turning right every single time, I believe. So that should allow us to repeat this pattern 4 times. And as we go through this, oh, I forgot to do the step through. I wish that was just the default one. As we go through this, try to think about how we could do this with a while loop. Maybe it's while not on a switch, we move forward, and then we use the if statement to toggle the close switch. And then afterwards, we turn right. So instead of even using the for loop like I've done here, apply that same logic with the while loop. And I'll put that challenge on you, although I kind of gave the answer, a little bit different to verbally give it, to then instead try it out. Coolio, our coding skills are growing. As we continue to develop them, you can use the while loops, the for loops, a mixture of both in order to solve the problems. My solution is by no means the best one, so experiment and see what works best for you and your brain. Okay, so let's take a look at our coding tool belt. We have functions, which are kind of like the commands we learned in lesson 1, the for loops, conditional code, our operators, and our while loops. For this challenge, we're going to choose the most appropriate tools from our coding belt in order to create the solution for the puzzles. There's no right or wrong answers, and try to be as efficient as possible with your code. And I do like these challenges, and the more we learn, because the way I might handle this solution might be completely different from the way that you handle this solution. I think because we are in the while loops lesson, and because I didn't use them last playground, I'm going to figure out a while loop for this one. So we have this pattern of gems that we are in the middle of. Well, the first thing I notice we need to do is definitely move forward. And then we're going to be under this gem. And I think this is where our pattern really starts. So I'm going to create a while loop. And for my condition, I want it to be like, okay, while I'm on a gem, I feel like I can be on a gem like 90% of this playground. I want a, kind of loop to happen. So while is on gem. And then what's the pattern here? So let's say we've moved forward. We'll then want to turn blue left. If we turn right, we're going to be facing this corner mountain. That wouldn't really help us out. We need to collect the gem. Now you might be saying, but hey, while is on gem, so isn't that going to turn off? Nope. The condition needs to be true to initially run this loop, and then it won't check for the condition again until all the code here has been executed. So even though we collect this gem, we're still going to be going through the rest of the code. So if after we move forward to collect this second gem here, it's still going to continue running. And you know what? We could even collect that gem right away as well. We'll then want to turn our character left again. So we'll be facing this square to the left of blue at that point. And let's go ahead and run it just so we can double check that it works and we are where we think we are. There we go. We're going to turn left. Okay, so then we need to move forward, turn right, and then probably move forward again, right? So we can be under this gem. So then this condition for the while loop is true again. You see how it's all coming together? So let's move forward, turn right, move forward. So this should place us right under this gem, and this while loop should carry us to complete this entire loop circle. Okay, here we go. We're going to collect the first one. We already know that this little part works, but now it's the connection piece. So turn left, move forward, turn right, move forward, and hey, we're on the gem, right? Every time that we get finished with this while loop, it's going to go back up to the top and check if that condition is true again. So again, oh, that condition's true. I'm going to collect those gems. Turn left, move forward. Are we under that gem? Yup, let's do it. And then it should stop because, hey, we're at the very end. There's no more gem to collect. If the gems respawned, we could theoretically do that forever. So you can choose whatever or combination of anything that you want to use to solve this puzzle. Use whatever you feel is most appropriate from your coding tool belt. Land of Bounty. It sounds like a pirate map. Okay, it looks like when we were loading in, and I'll just double check and verify. Yeah, okay, so our terrain, what kind of is apparent. The toggles, the gems are randomized every time we run our code. So we're going to experiment to find an efficient solution that works for you, us. In this challenge, the length of the platform, the puzzle can vary, okay, but the arrangement of switches and gems is always the same. There are many different approaches. Okay. So the length of the platform and the arrangement of switches and gems are always the same. Okay, good to know. There's always going to be the 3, 3, 3. I think what we're going to do is maybe use our blocked scenario here and say like, well, we're not blocked because, okay, let's say we go all the way to the end here and it's like 3 or 4 extra tiles down here. We're not going to be blocked until we get to the end here. It seems like there's always like a, hey, you can't go further moment. So maybe we use a while you're not blocked. And then when we get to the end, we turn around. Does that make sense? So let's go ahead and first figure out how we can solve the columns. And I think we could use a function for that. And we can bundle the toggled or untoggled switches as well as the gems. Oh, I didn't want a for loop here. I wanted a function. And we can actually bundle those two ideas together. So we'll call it solve column. I think that's how you spell column. Within this column, we can use our while loops. So we can say while we're not blocked, right? While we can still move forward. And again, even when we're heading back this way, if we do a zigzag pattern, where blue standing behind them, that's blocked. We can't go down to where the water and lily pad are. So let's do our while. And we're going to do the opposite with our exclamation point is blocked. So while we're not blocked, then if we remember from, I think it was challenge 2 or 3, we use an if statement. And this is how we're going to be able to determine, I don't know why the if statement sometimes is hard to click. This is where we're going to determine if we're on a closed switch. If that's the case, toggle it. Otherwise, we don't need to. Otherwise, if we're on a gem, we can collect it. And while I'm saying otherwise, you might be remembering, oh yeah, else if. Look at that. Yeah, here we go. Okay, so if is on close switch, we're going to go ahead and toggle the switch. Outside of our if, again, if you want to click on the squiggly braces here to make sure we're on the right spot, we'll do our else if, then we'll add our squiggly brace here. So else if is on gem, go ahead and collect the gem. We used this exact logic before, just not within a while loop. Handle either of those conditions. All right, now still within the while block. Again, feel free to make sure you're still within there using the braces and you're in the correct spot. Still within that while block, we're going to then move forward, which is going to loop us until we are blocked. So I think that's going to be our function. So in our function, we're using a while, if, else if, and we're even using the operator with the exclamation point inverse. Outside of our function, so make sure you're not with any of those other braces, this is where we're going to call upon those functions or other commands. So let's first do our solve column and ensure that it works. Then we can handle the repeating and the turning around and kind of zigzag patterning. Oh, we have a really long one. Cool. I mean, we got to the end. We're now blocked, and our code block has stopped running. Totally fine. We still need to be able to figure out the next solution. So in order to turn around, we can probably turn our character right, move forward, and then turn them right again. So that'll kind of do 180 degrees. If you want to turn yourself right twice real quick in real life to simulate the turning, that's essentially what we're going to be doing. So let's turn right, move forward, and then turn right again. Now you might be saying, okay, let's just repeat this, another time. I'm going to show you real quick. So let's do another solve column real quick, and I'll also do these step through codes so it's a little easier to follow why that might not work to do the turn right again. You might already be kind of figuring it out, but let's see why if we were to do another turn right, it wouldn't work. So no matter how long or what the switches states are, etc., we're able to solve the puzzle. So here's our turn right, move forward, turn right. I'm just going to speed it up after we know that the gem logic works. Else if is on gem. Let's see here. Select the gem and then go to move forward. Great. So when we do reach the end of this platform here, the reason we can't turn right is if we're looking at Blue's perspective and we turn right, we're going to just do this loop infinitely, right? So instead, we'll want to turn left, right? Move forward, turn left. And that's going to allow us to be on the last column here. We'll then want to do one more solve column and we should be good to go. So I'm just going to run this at the fastest as we know our logic has been working so far. We've already been spending some time on this playground. And there we go. All of our hard work is paying off. You might have even found a different solution than I did. Alrighty, nesting the loops. So we're going to use a loop inside of another loop to move around the spiral. I mean, we've kind of already done that, right? Even with our conditions within a loop, I'm sure we'll be able to knock this one out of the park. So while condition, oh wait, that looks really cursed. Okay, we have to remember how our braces work and how the layering and the outer loop and the inner loop are going to be able to work in tandem. We also need to be able to adjust our inner loop to move forward until there's a gem to collect. The inner loop is probably the second one here, and I think that's our answer there. So until there's a gem to collect. So what can we use there? Well, we can use is on gem, and remember our opposite. So while we're not on a gem, essentially to me says, while there's still a gem to collect. And we even see in step number 1, there's another hint too. Add the condition to the outer loop, repeats until our character is blocked. Well, what can we do? Character is blocked. We want to repeat it until it's blocked. But while we are not blocked, run this. While we're not collecting the gem, while we still have a gem to collect, repeat this. The hints on this one are a little bit hard to see. Let's see in number 3, once the character reaches the gem, collect it and turn left. Yeah, all the hints are in the step 1, 2, 3 here. So we want to collect the gem. And something you might notice real quick is after every single gem, we'd want to turn left. So we go like this way, let's rotate our camera, boop, 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 boop. We're walking this way, turn left. So, turn left. The only thing we don't have here is while we're not on a gem, but we need to be able to move blue, so move forward. That should just work. So we're gonna have 2 while loops, and let's run through this step through our code. I know I kind of did the hints out of order here, but hopefully everything made sense. So we're gonna check, you know, are we blocked? Nope, we're not blocked. Are we on a gem? Nope, we're not on a gem. Okay, so here we're on the gem, so we're gonna collect the gem and turn left. Are we blocked? Nope. I'm gonna move forward because I'm not on a gem. We're just gonna be repeating that loop. So you can see how with the tracker, it's kind of ping-ponging between these two. And now that we're finally on a gem, we're gonna go to the collect gem, turn left. We're gonna check, are we blocked? We're gonna check, are we on a gem? And then we're gonna go back to continuously checking if we're on a gem or not. And it's just gonna ping-pong between these two things. So when we're on the gem, collect gem, turn left. We're not blocked, okay. So let's go through this inner loop again. Repeating this inner loop, repeating this inner loop. Okay, the condition is here, collect gem, turn left, we go to the top loop, not blocked, is on gem, right? So it's one of those things where the outer loop is going to be kind of this initial condition, and then the inner loop is the thing that's running and running and running, and will then escape the loop, we go back to that initial loop, and repeat it over and over again. This is definitely one that even as you do it yourself, I recommend using the step through my code option through this little, almost looks like a speed gauge in the bottom left, where you can choose how your code runs. So nesting loops is something that can be pretty cool. I do want to share the words of wisdom and advice that is within this little text box here. If a while loop boolean, so that true or false value, is never false, your code will run forever in an infinite loop, which could make your computer, your iPad, your device absolutely freeze. So always make sure when you're using these while loops that there's some world, some scenario where it may become false. Otherwise, you risk having that infinite loop and freezing. That's not good user experience. All right, random rectangles. How many more do we have left? Ooh. This one and another, so 2 more. Use nested loops and conditions to move around a changing world. In this puzzle, run it a couple times to see how the size of the puzzle world changes while the shape remains the same. You got it. Okay, so this one's more rectangular. This one's even thinner. We only have like 3 tiles of water. All right, interesting. This one only 2 tiles of water. Okay. So we need to use while loops. We'll probably use our is blocked again because it looks like there's just nothing but the void. That sounds like really dark. But there's nothing kind of blocking blue here. So I think our is blocked condition is going to be playing another big role. And we're also going to be using our nested loops to create a solution that will work no matter what the size of the puzzle world is. Okay, so let's create our first while loop. So while we are not blocked, I'm going to select our is blocked, and right before it, use our opposite, which is that exclamation point. So while we're not blocked, we should probably be moving forward. That makes sense. But what about the other condition, right? Every time we reach a corner, because it is like a square rectangle shape, we'll need to be turning blue right. How can we do that? Should, you know, while it's blocked, move forward, turn right, that wouldn't really make sense. So what we need to do is we need to use our nesting loops. I'm going to quickly get rid of this move forward here. And I'm going to add another while. So we're actually going to use the is blocked again and the inverse of is blocked again with our move forward. Outside of that, but still within our first outer loop as we called it before, I want it to turn right. So while we're not blocked, we're then going to go to the nested loop and we're going to move forward. Once we are blocked, we're going to say, okay, I'm going to exit this loop. I'm then going to turn right. At the very end of our playground here, we will be absolutely blocked and we'll need to then toggle the switch. I know nesting loops can feel a little bit confusing, so again, we'll just go through the step through my code and I'll try to explain it the best I can. So blue is going to move forward here, saying, okay, I'm not blocked, still not blocked. And again, I'm just bouncing between this nested loop. Okay, now I am blocked. I'm going to then turn right. So I'm not blocked again, and move forward. Not blocked, move forward. Okay, so we're gonna get up here and we're gonna say, oh, we are blocked. We're gonna jump out and turn right. We're no longer blocked again, so we're gonna go exit that loop. I'm gonna check that condition again. Oh, I'm not blocked. And then, oh, yeah, I'm not blocked. We're using that turn right to essentially escape the loop, and then we check the condition again, right? This time we're blocked, we're going to turn right. We are definitely blocked, so this condition hasn't been made true by turning right, so we're just going to say, okay, we're done with this entire while loop. We're going to go to the next line of code, which is the toggling of the switch. We have one more you're always right. I mean, I knew as I was I don't have that big of an ego. You're always right, and we're going to toggle all the close switches and collect the gems, and we're going to choose from our existing skills, so that tool belt again, how we're going to be solving the puzzle. It's okay if we don't get it right on the first try. Professional coders, we hardly get anything right on the first try, absolutely. Debugging, working through challenges is something that's really important. I think I have a solution in mind here, although the teleporter is making my brain hurt a little bit, but maybe we can figure it out. I think the while loop is really going to come into play, and I believe a nested while loop as well. So what I'm thinking is we use our is blocked with the inverse again, and we also maybe have an if statement to check if we're on a closed switch. I'm just going to make sure that these switches do change. Okay, these switches do change when they're open and closed, so we'll use an if statement for sure to toggle it, as it looks like we do get blocked often. So see here, we're going to move forward. We can't go up this little step here. There's no stairs. So we're going to get blocked and we'll need to turn right. So let's say we go through this teleporter. We get blocked here. We need to turn right. Right? We get blocked on this left corner here where my mouse is. We need to turn right. We need to turn right. It's that square rectangular pattern that we had before. So let's go ahead and do a while. We'll do our inverse of is blocked. I've been loving this one. I think this one feels like a hack for, for how good it is. And we'll need to be moving forward, right? Until we reach that wall, we're going to be moving forward. Now we also need to handle the switches. We've done this before with our conditionals. So if is on closed switch, toggle said switch. When we are blocked, so we'll go outside of this while loop. While we're not blocked, we'd want to turn right. Right, so that should be the basic pattern. I haven't included how to collect the gem yet. That's something I think we'll need to figure out a little bit later. Okay, so we're toggling. We're blocked. We're going to turn right. Nope, that didn't work. We turned right, and then Lou was like, no, I'm done with this. See, the problem is we don't have a condition causing us to really keep going. Does that make sense? Because we turned right, but then there's no way to call this while is blocked again. We almost need to nest this. And I'm thinking, yeah, I mentioned we didn't collect the gem yet, or include logic to do so. I'm thinking that's where we include this. We could also use nesting of the loops. So I'm going to do another while loop here. The while condition in code. So while, and use the opposite is on gem. So while we're not on the gem, I'm then going to take this brace here, I'm going to grab it, I'm going to drag it all the way to the bottom. So now we're nesting everything within this while is not on gem, because that's going to allow us to, once we get to this turn right, and say, okay, this is done. Can we check the while loop again? Allow us to repeat those actions. And then at the very end, so outside all the other braces, when we're finally on that gem, we're going to collect it. I think this might work. Let's go ahead and step through our code. So we're not on the gem. We're going to move forward because we have that nested while loop, remember? Move forward. We're going to check the switch state. It's toggled. Move forward again. This one needs to be toggled. Okay, so we're still not blocked. Move forward, no switch. We are now blocked. We're going to turn right, and then we're going to check. Are we on the gem? Nope. Okay, I'm going to go into that code loop. Are we blocked? Nope. Move forward. I think this might be the solution here. Because this is a pretty long playground, I'm just going to run it a little bit faster until we get closer to the gem. Let's go blue. Okay, we're slowly approaching the gem, so I'm going to swap it back to this mode. Move forward. Are we on a closed switch? Nope. Are we blocked? Nope. Are we on a closed switch? No. Are we blocked? Yes. We're going to turn right. Are we on the gem? We're going to collect it. And that is the end of our loop. We've finally met the condition of false state. So we were finally on the gem. Therefore, we exited all of this and did our final action of collect gem. Ooh, while loops, nesting while loops. That got a little bit more advanced than I had expected, but we did it. Celebrate, we've now just completed while loops. This is a pretty intense topic, especially when we're nesting. The concentration effort, using the different tools in our tool belt, the inverse operator especially, the is not blocked, did some heavy lifting here. Now, the next episode, next week, it'll be time to learn about algorithms. So algorithms, it's putting everything together even more tightly. Not just some scary math term for algorithms, but simply a set of steps to solve a problem. Whether you're collecting every gem, navigating a tricky maze, you'll learn how to design a plan, break it into code, and make your solution efficient. This is where your coding brain will really start to kick in. So next week, we'll be taking a look at smart algorithms in Swift Playgrounds. And I think that is the last topic actually for Swift Playgrounds #1. So eventually we'll be graduating into Swift Playgrounds numero 2. I think I said that right. Anyways, dream big, code bigger, and have an amazing rest of your day.